I wanted to mention how to do the calculation part of a hypothesis test using the calculator. So if you remember in our first example, we had a hypothesis of the population proportion being 0.15, and we got a sample whose proportion was 0.095, 19 out of 200. And that led us to this z-score and led us to this p-value. So I wanted to show how to do that on the calculator. On the calculator, you, under the stat button, you arrow to the test menu, and we're doing item 5, which is one proportion z-test. The p subscript 0 is the p according to the null hypothesis, so that's 0.15. And then what does our sample look like? Our sample is 19 people lived on campus out of 200. Our alternative hypothesis says not equal to, and then just calculate. And there's our value of z, and there's the p-value, almost exactly the same, 0.293, and we had 0.292, just a little bit of rounding off differences there. So, and notice that the calculator's already done the multiplication by 2 for us. In the second example, we had a p-hat from our sample of 0.12, which gave us a different z-score and therefore a different p-value of 0.23. So if we redo the test on the calculator, stat tests one proportion z-test, and this time our sample was 24 out of 200 living on campus. Everything else is the same. And there's our z of negative 1.19 and our p-value of 0.23. Same p-value we got here. And then our other example was on doing a one-sided test where the alternative hypothesis said less than. So let's just run through that right quick. If we do this stat tests one proportion z-test, and our p from the null hypothesis is still 0.15, our sample has 19 out of 200 living on campus. Now our alternative hypothesis says less than. And so the main difference here is the calculator is not going to multiply the probability by 2. So there's our z of negative 2.18 again, and now a p-value of 0.0146. So that's how you do a hypothesis test for a proportion on a graphing calculator.